So hey there guys, in this video I'll be showing you how I made these little mini shotgun microphones for my digital camera. They're directional, they're noise cancelling, and they're under $10 in parts each to make. Now I did use a 3D printer to make these, so you'll likely need a 3D printer as well if you want to follow along. But the main purpose of the video is just to showcase the process of designing, making, and testing and iterating on the process of making these. Now you're listening to one right now, currently on top of the camera that I'm recording with, so if you like the way the microphone sounds, it might be worthwhile to build. The purpose of the video is mainly just for entertainment. And if you are interested in providing any ideas or suggestions on how I can improve the design as we go, drop those in the comments below, and maybe in a future video I'll try to review all the feedback and make a better microphone. All the designs will be available online. Check the descriptions for links to those files. The first step in building our own microphone is getting a microphone capsule. And the microphone capsule is perhaps the core of the microphone we're building. Now, in some ways, most of the work is technically kind of done for us when we buy the capsule, but a microphone capsule is only a couple bucks to buy. And the time and effort going into building the rest of the microphone is going to be substantially more than the time to just order it. But that said, there is still an effort in buying a microphone capsule and figuring out which one you want. So we're going to go through the steps of purchasing a microphone capsule and selecting an appropriate one. I recommend we go to digikey.com or digikey.ca. They tend to have very competitive prices. Unlike ordering from Amazon, the prices are kind of at cost or very close to it. So you're not paying $20 for a part that this site will charge you 50 cents for. Unlike ordering from AliExpress, on the other hand, DigiKey ships same day usually, so you normally get the item delivered to your door next day, maybe at most 2 days. So I do recommend digikey.com or digikey.ca. And what we're going to do when we go to the site is just type microphone in. And we're going to get a list, and we're going to click the microphone category. And so what we see is 1,656 microphone capsules are available to us. And this might seem a little bit overwhelming at first, but it's pretty easy to go through. We're going to start on the right-hand side, and we're going to say to ourselves, what type of microphone are we trying to build? We want something that's directional, that acts like kind of like a shotgun microphone. So we're going to try to pick a unidirectional, which is one directional, and noise canceling. And we're going to ignore omnidirectional, which is picking up sound everywhere kind of evenly. We don't want that, so we'll select everything but that one. We're also connecting this microphone to our camera. Our camera has an analog input, 3.5 millimeter. So we don't want a digital one, we only want analog. Digital is if you're trying to build something for a microphone array or some sort of smartphone application where you're connecting directly to a digital chipset and not into a something like a camera. When we get to the type of microphone, this is a little, you can have a little bit of flexibility here, but I would strongly recommend you stick to just the condenser microphones. I think we got everything we need filtered. We're going to click also in stock, and we're going to hit apply. So now we're down to 37 microphone capsules. This is where you might feel a little more comfortable now. We're talking about frequencies and signal to noise ratios. So what we're going to look at here is probably just the frequency. We generally want something that is going to be of a certain frequency and of a certain signal to noise ratio sensitivity. So here, for example, we have 50 decibels, and we don't want that. The human ear can generally differentiate noise from a signal at around a range of around 60 decibels. So at around 50 decibels, you're generally in the audible realm of noise. You'll be picking up a constant hiss in your microphone regardless of the signal almost. And so we don't want that. And really even 55 and 56 is on the low end in my opinion. So just for fun, we're going to say 60 to 72. And that will give us at least a technically noise-free solution. And that would, I hope, be the goal of what we're trying to build here. When it comes to frequency range, anything above 100 hertz is great for cutting out background noise, wind noise, hum, 60 hertz hum, things like that. But when you pick 100 hertz or higher, you also tend to cut out some of the deeper earth, the deeper organic tones in like your chest, that rich sound. I tend to recommend 70 hertz, but just for fun, we're going to go 30 to 100, 30 to 70 here. On the upper end, we also want to make sure that we're getting at least 12,000 kilohertz if we're trying to record a voice. Anything below 12,000 kilohertz, and I find you start to lose the sparkle. And so that's a good range. A lot of people can't hear above 15 kilohertz anyways. So although the human ear technically can get around 20 kilohertz, that range in that realm doesn't really apply to most people, and it doesn't really apply to vocal pickup. If that's your application, at least, you generally don't need to worry too much about 20,000 hertz. So we're just going to select those frequency ranges and then hit apply. So now we're down to 3 microphones, and we can scroll down and we can see them. Fantastic. I've ordered all these microphones already in the past, and they're all pretty good. I would strongly recommend you order more than one microphone. If you're not happy with it, it's fairly easy to swap it out and try another one. And if you look at the cost of these microphones, they're $1, $2, $3 Canadian. So you can buy a dozen of these microphones and test them out. If you're intending to hand solder these microphones, you might want to buy at least 2, because if you mess up your first try, it's pretty discouraging not having a second capsule to try on. These microphones are very small. They're about 9 millimeters in diameter, 9-10 millimeters. And so trying to solder, if you haven't soldered before, onto these is quite challenging. Now, despite the fact that we've spent some time filtering and trying to find a good microphone, and I did order all these, and I have tested them all out, and they're all pretty okay. I found through a very, I suppose, tedious search, where I didn't really go through any filtering. I kind of manually went through a list of 800 or so microphones. I looked at each individual one to see if I could find things that were overlooked, things that were filtered out accidentally, and I found this guy. And this is what I've ordered for this project. At least this is what I came up with as a first pick in microphones. And this one has 100 hertz to 12,000 kilohertz. It has a voltage range of 1.5 to 9 volts. It has a fairly high signal to noise ratio of 72. So it's 100 hertz. So it's not as deep as I would have liked. I would have preferred 70 hertz. But 100 hertz should be pretty good. That's noise rejecting. It's unidirectional. And 2 kiloohms is pretty standard. 1.5 volts to 9 volts is pretty standard. The voltage of 1.5 volts is a little bit low. Normally I'd go for around 2 volts, 2.2 volts if I can. But this was a different choice compared to the previous microphones I ordered. I wanted to try something different this way. It's not perfect, but I gave this one a go. The main reason I gave this one a go for this particular video is it comes pre-soldered with wires. And unlike the other options, which I showed you a moment ago, those 3 other ones, those were not pre-soldered. And so soldering them is a step that is very challenging, and I think we should skip that. So if you want to try the other microphones, they might have a little better technical performance. Whether they sound better or not is up to you to decide, but this one is fairly easy to work with. The price is $5, so it's a little bit more expensive per capsule, but you're not going to break one when you're soldering it, at least. And so this is what I went with. There's a little data sheet button we can click on here, and it opens up a PDF. And we can see the detailed specifications of this microphone here. What we can see also is everything we talked about here. It says hand soldering. At maximum, you should solder that pad for no longer than 2 seconds. If you apply heat for more than 2 seconds, you could cause damage to the microphone, and that damage could make the microphone stop working, or it could make the microphone sound awkward. I've destroyed a few microphones already that sound very, very, very tinny, and I believe that I destroyed them in the process of hand soldering them. So having it pre-soldered with a wire is recommended for best performance there. The design, there's little holes in the back of the microphone, and those holes are useful for noise rejection. So the audio noise gets in the back, and the microphone uses that noise that gets in the back to filter out any sound that's not coming from the front of the capsule. We have a little diagram of the audio pickup, and yeah, we see kind of like where the noise rejection patterns look like. So it does seem to dramatically reject noise coming from behind the capsule, and it tends to have a fairly decent pickup pattern coming from the front. It looks like it's adequate for the human voice, although it's probably not as bassy as I would have preferred, but we can always adjust bass in post-processing if we need to. This is a wiring diagram showing you how we can wire the microphone up in a circuit. Usually most modern cameras and most modern recording devices will probably have the circuitry built in already and have some default values. So you probably don't need to worry about this. We can just assume the simplest of wiring cases. Now, if I'm incorrect on any of this, please correct me in the comments. This is all my interpretation. So this is the model number if you want to copy me. What you're hearing is this particular microphone now. Okay, and now that we are ordering this product, I've actually ordered over $100 worth of items, and it came shipped free. So I was able to pick up a few of these microphone capsules for fairly cheap, $5 Canadian each plus tax, and the shipping was free. Next, we're going to get on to designing our apps. We're going to get on to designing our case for the microphone and the mount and other aspects like that. Next, we're going to go to a site called Tinkercad, and this is a free site. It's hosted in the cloud, so you don't need to download any software to do the CAD design, and it allows us to build our own 3D models that we can print out with our 3D printer or get printed out in a remote service. Okay, so this is the work plane. You can right click with your mouse to change perspective. You can highlight with the mouse, and you can hold shift down and right mouse click on a PC at least to move the plane around. So it's pretty easy to navigate. It takes a few minutes to get used to it, but that's about it. You can zoom in with the mouse wheel, and what we see on the right hand here is a bunch of different designs, different shapes we can use. And so the main idea here is we can drag a shape in, and we can then change the size of the shape with these basic movements, okay? We can then drag in these transparent shapes, and they act as negatives, they're holes. And so when we highlight the red square and the hole, and we press this button right here, it groups those two items together, and the hole takes a bite out of the solid shape. So if we were to print this, we would get a square with a notch taken out of it. And there's lots of different shapes you can grab, and you can move them around, do things like this. You can, change size. You can also rotate with these rotation buttons in every direction. And just by piecing together these objects, grouping them together as you go, you can build a 3D model. And so just for the sake of time, I'm going to fast forward through the development of the first microphone design I'm going to be trying. And that's probably going to take a couple hours, but I'll shorten it down just to a few seconds for you guys. So basing the design on the microphone capsule we bought, which is 9.7 millimeters in diameter, I'm making sure that the inner part of this microphone tube we're making is at least 9.7 millimeters. I ended up actually getting it closer to 11 millimeters on the diameter. I made sure that there's lots of room for the air to get in and out of the microphone capsule, just because it is noise cancelling. It needs sound to get in from the back and the front. I decided to make the capsule, the entire microphone, a little bit larger than I originally intended, so it ended up being a few inches in length. I added a little slot for the microphone wires to be placed in, and I tried to just have a little bit of a clip so when I put the microphone capsules in, it could lock in place. Last, I added a hot shoe mount so I could attach it all to the camera. A lot of fiddly stuff here. Wasn't quite sure how I was going to do the back of it, the cap, so I ended up doing that a little bit later. So this is the first design I came up with. There are a lot of slots to let sound get in. You can't just seal it up, otherwise you wouldn't get any clear pickup. And the idea is there would be one capsule on the top and then one capsule on the back, and they'd be both facing forward, or one would be facing forward and one would be facing back. If you face one in the forward direction and one in the back direction, the idea would be you could record yourself if you're behind the camera, and you could record what's in front of you to another audio channel also. So you could have left and right audio channels on your camera being used for front and rear. In my case, I was actually kind of curious to have them pointing in the same direction, both forward, and I wanted to play with this concept of phase shift. So the front microphone capsule will have a different phase than the microphone behind it when recording things in front of the camera, but things that are on the side of the camera, we should see that the phase between the two microphone capsules are in sync. And I was trying to see if perhaps using machine learning, I could use that small phase difference between the two capsules to do some noise cancellation. But there's lots of other ways to do it, of course, but I'm going to try to make that another project. This is my first design, and we're going to print it out. So let's get to that. Okay, so I'm currently 3D printing out the shotgun microphone case. I have a homemade fan that sucks air out and it goes through a carbon filter. And these are just two computer fans. When I'm 3D printing in my basement, I just want to get rid of any fumes that might come off the 3D printing filament. It starts to agitate my lungs after a long time. Temperature 200, bed temperature 60. Put some tape on the table so I can peel off the moth if it's stuck. And this particular printer is 300 Canadian, but you can get pretty good 3D printers off Amazon these days for about 200 Canadian, and they get the job done. I'm just using some, I think it's PLA 1.75 millimeter filaments, just very basic stuff. Yeah, and it's been going for quite a while now. Okay, so I bought these two microphone capsules. You tell on the back that they're noise canceling. The little holes in the back imply directionality. And the model is a CMC 974537L100. And I bought it from DigiKey. They were $5 Canadian each. Okay, so the first attempt here was a failure. It was just too fragile. That, and it was too small, so the microphone did not fit in properly. I also printed it with a support, and the support printed on the inside, and getting the support out just was too hard. I ended up breaking it trying to get it out. So I'm going to print it again, but this time without a support, and I'm printing it a little bit larger, so the microphone will actually fit in this time. Okay, so I finished printing it, this time without any support. I noticed that the hot shoe's a little too long, so I'm going to have to cut that down a bit. And I haven't decided yet if I want to plug it into the camera directly, so a short cable, or do I want a long cable and run it to like a Zoom H1n. I'm going to assume I'm going to make this very small, and if I need to hook it up to a longer cable, I can use an adapter. Okay, so it's finished printing. Took an hour, a few minutes, an hour. Front, and the back, and we have a little bit of printing damage there, but I'm going to try this out and see if it works. Okay, so I'm going to try this out. It's a little stiff, but it's locked in place now, and unlocking it comes off. Awesome. Okay, so I fed the one microphone in to the front there. I pushed it in through the hole underside, and just gently using a little pin, or in this case I used a little watch tool. I just kind of pushed it down gently with that pin, and yeah, got it down into the front, facing outwards. So I'm going to put the other one in now, and this other one I'm going to put in the back. Okay, and if you can tell, there's a little slot here, a little groove for this cable to go into. So when I put the other microphone in, it's not going to interfere, and this other microphone is going to go in about that far. And we should have about 4 centimeters of separation from the front of one mic to the front of the other. Okay, so I got the other microphone in. It's right there. 2 cables coming out. There's the other one up front. I'm going to tie a little knot with these wires coming out, just so that, well, there's a little bit of an anchor. Okay, there's the anchor. Just a little knot, and when I put a cap on the end here, the knot will make sure that if someone pulls on the audio cable, it won't put direct force onto the mic capsules themselves. It will put force on the knot, and hopefully that will give this a little more ruggability, durability, ruggedness, that's the word. Okay, so I tied the grounds together. The black wires are the ground. The red wires are left and right, well, front and rear microphones. So one of the red is the signal for one of the microphones, and then the other red is for the other microphone. And the black is the common ground. And we are going to take a audio cable. Now, Here's an audio cable. I got this from the dollar store, or just wherever you can get really cheap audio cables, or a bin of old headphones. And I cut it, and as you can see, there's 3 cables, 3 wires. One's all copper. That copper shielded one is the ground. Then we have red and white. One of those, red and white, will be the front, and the other will be for the rear microphone. And the ground is shielding in this cable, so it kind of surrounds the cable and tries to help fight noise. If you can find a cable that has a ground that's kind of shielding, that's coiled around the red and white, that will give you the lowest noise. But at a minimum, you just really want 3 wires if you're going with this front and rear microphone setup. If you just buy one microphone capsule and you just put it in the front, you only need a 2-wire audio cable setup here. And you don't really need to know where these things kind of connect to here, because we just are going to assume the ground is correctly set up. And so we're going to wire the black to the ground, red to red, and red to white. Okay. One thing I should mention is if you have some heat shrink, that would probably be helpful here. So you can just buy this. I'm using 2218 gauge heat shrink tubing, and I'm putting it preemptively onto the audio connector. So when I wire it, I can then push that heat shrink up and make a nice, strong, secure wrapper for it. I'm going to solder these together, and I'm probably going to use a little bit of something like electrical tape or something, probably to isolate those individual connections. We'll see. Okay, so I hand wound the wires, and I'm going to solder it all up next. It should be pretty easy. The solder is just going to make sure that we have a solid, strong connection between each of the wires. And I've soldered connectors. Really bad job at soldering. Sorry, guys. I've been soldering since I was in grade 10, and I still am really bad at it. So I'd probably say soldering is an optional step, but if you want this thing to last, consider soldering. You can buy cheap soldering irons on Amazon, but you could just twist the wires together, and that would work in a hacky way. Okay, so next, just going to wrap up the exposed wires with some electrical tape. So I don't know if you can tell, but what I did is I just folded a small piece of electrical tape over the cable where the solder was, and I just cut off the excess. I really don't have a whole lot of room if I want to put the shrink tubing on, so I'm just going to do as little as I can here. Okay, I did the 2 red wires, and I'm not going to tape up the grounding cable. There's really no need to do that one. And so I'm just going to put the shrink wrap on and get a hot air gun, I guess, next. So I worked the shrink tubing on. I've yet to add any heat to it, but it might have been a little too small, but I still got it on. Just something to consider. Okay, so now the moment of truth. I have a Zoom H1N here. This puts out a little bit over 2 volts into the mic input port. It's also stereo, so we'll be able to see if the microphone works. So I'm just going to turn it on. And the idea should be we should see audio into both channels. This is a test. Okay, so what we're seeing is audio into both channels, and it looks like it's working. The volumes are not the exact same, so I did not cross any wires, thankfully. We're getting audio to both channels, so it means I wired both connectors right. If I go quiet, the noise drops. So perfect. It's wired up. I'm just going to put a cap on the end, and we're pretty much done. Okay, so I made this little part, and I 3D printed it out. Here we go, and yeah, it's nothing special. It took a few tries to get it the right shape. Here's the microphone. I'm going to pop this in to the back of the microphone, and then I'm going, well, at the same time I'm going to add a little hot glue. And I'm a big fan of hot glue. Hopefully that will keep the wires from kind of ripping around. So a little glob right there to hold everything in place. Not a lot, just enough to keep the cap in and keep the wires from getting worn. Okay, so it's done, and the hot glue is a little bit rough, but you can see that I was trying to add a little bit of strength and rigidity to the cable there. I didn't want it to wear from flexing too much on those little wires, so that just is my way of handling that. And you can see that there's a little bit of a little knot of cable at the end there. That knot is meant to just make sure that if I do suddenly pull on this cable, the knot gets pulled on rather than the microphones. I don't want the solder pads to get ripped off. Yeah, I'm going to now test this little guy. There's no shock absorption really or anything like that. It's a pretty basic small microphone, and that was my goal. Okay, so this is a test of the Panasonic GH5S with the microphone we just made attached. It's connected, as we saw a second ago, 3.5mm audio out into the microphone jack. I'm about a foot and a half away from the lens and about maybe close to 2 feet away from the microphone on the front microphone. Yeah, it's pretty cool. And I can see that my mic levels are recording pretty well. It seems pretty good. I have a computer going in this room, so you might hear a background fan. Should be hopefully quiet because this is noise cancelling, and that is the fan's kind of more or less behind the microphone. And I'm going to unplug the microphone now just so you can hear what the onboard camera sounds like. The microphone's unplugged now, so we're using the built-in GH5S microphone, so the built-in camera microphone. Nothing in the room has changed. The camera's in the same position, about foot and a half away from my face. The microphone's closer to 2 feet away from my face. Yeah, so that's how the GH5S microphone sounds compared to what we saw a moment ago with our newly made directional microphone. And just again, this is the microphone we made, plugged into the GH5S. This is the microphone we made. Nothing in the room has changed. There's a little computer fan going still. I think there's 4 120mm fans going away, but it's not too loud. And yeah, this is how it sounds. Not bad, huh? So it's the middle of the night and we're testing our microphone we just made outside. We have it connected to the GH5S by Panasonic, and it's a pretty quiet night. There is a gentle breeze, so we're going to have to test how well the microphone handles wind noises. I don't suspect all that well. There is a freeway, a highway, about 1 kilometer away, and so although it's behind the camera, I can definitely hear it. It's the loudest thing outside right now. If this microphone works well, we should be able to reject that background noise pretty well though. And to compare it, we are going to compare against the built-in microphones of the GH5 and a lavalier microphone. Now we're testing the built-in microphone on the GH5S. This is a $2,000 US camera, so we should expect to get pretty good performance out of the built-in microphone. We're at a distance that is pretty good for vlogging, let's say. We could get a little closer even, and yeah. So now we're testing my lavalier microphone. This one's by Movo. It's like 20 bucks on Amazon. And I have it recording into my H1N by Zoom. Okay, so I was facing some problems with wind noise. So I put a little cat toy on the top of the camera. This one I picked up just for a couple bucks. It's actually my cat's. So I'm going to have to get him a replacement now. And maybe I'll find one that's black or gray instead of this light gray and white one. There's a little Velcro zipper on the other side, and with that you put in catnip. But instead of putting catnip in, I put in the microphone. And it fit pretty much perfectly. And yeah, so hopefully it works as well as I hope it does. I'll test it in just a second. But it's kind of cute, and it seems like it should do the job. I've also been playing around with the idea of putting a right angle microphone connector on the microphone rather than the straight 3.5. I put a right angle 3.5 on, just via an adapter there. But I might make that permanent if I like it enough. Yeah, so let me test it. We're back outside the next day testing the microphone again. There is a gentle breeze coming from the right side of the camera. Today I've added a little cat toy to act as a little microphone windscreen. It's a little fluffy cat toy. I'm just adding it on top of the microphone to shield it from the wind. The wind is coming right now. It's about the same as yesterday when I last tested. With any luck you will hear less or no wind noise at all. But I am about a meter and 1.2, 1.3 meters away from the microphone currently. So all the conditions are about the same as yesterday. There's some traffic in the back and fairly moderate wind now picking up. Okay, hopefully this is a good test. And just for a comparison, this is without our microphone. This is using the built-in GH5S microphone. So this is the built-in microphone of GH5S. Same setup as just a moment ago noise. So the microphone we made worked out pretty well. It worked a lot better once we put the little cat toy on the top. Now this microphone was built with two microphone capsules in it for front and rear. I had them both facing front when I put them in. The reason for that is I'm trying to use them to do some noise cancellation in software using phase shift. That's another project that I'm working on. For most individuals, you might want to put one facing forward and one facing backwards, so you can have a choice of picking up your own voice or picking up what's in front of the camera. If you're behind the camera, let's say you might want to talk. So you can get two channels, front and back, rather than left and right. So that's kind of nice with this camera, with this option, this microphone. I made this other option though, and this design forgoes the two microphone capsules. So there's only one capsule on the front, there's no hole in the back, so there is only really one place for a capsule. And so you put a directional microphone in the front here, like I have here, and you don't put anything in the back. Now this way it only picks up what's in front. It costs quite a bit less, $5 less to make. And finding a cable that supports just a single mono channel is pretty easy. And if you have a stereo cable, you just wire the left and right cables together and it will make it mono. So you tie the red and white together, and the blacks, if there's more than one black, you tie together, otherwise it's just the ground. And you can make this. And if you want to do what I have done is, well, I bought these for some headset microphones in the past, but this pops on the top of this almost perfectly, and it kind of replaces the need for a large fluffy. And I'll just pop that on and show you how it looks in a second. So there we go. I added the foam to it, and it fits perfectly. I'll put a link if I can find them. I got these on AliExpress, like $5 shipped. Very, very affordable. I got a dozen of them for a few bucks, and it works pretty well. It should perform the same as the foamy here, or close to. And you can always add one of these on top of this if needed as well. But it looks pretty professional, minus from the printing damage when I installed the hot glue and I put the cap on the back. The hot glue caused it to soften and I kind of crushed it. And in this one, I also had more room on the interior of the microphone. Since there wasn't a capsule here, I could knot a cable on the inside, and I didn't have to have a more fragile cable coming out. So this design actually is probably what most people might want to build, just a single capsule on the front. In that case, it's more of just like a cardioid pattern pickup. So it's not quite a shotgun microphone. This other one I'm building here is trying to be more of a shotgun style, but I'm going to have to turn to software to do that. I'll probably do that in another video. But all these designs I'll host online for you guys, so if you want to print one out or have one manufactured at an online service that prints them out for you, you can do that too. I'm pretty happy with the designs I built so far, but I'm trying a different design here. I made this microphone. It's a oversized fat tube, and it has a little hole in the end. This is the cap. The cap is also designed with a 3D printer. It has little perforated holes in the front. Sand down the sides because it was a little bit rough. I'll fix that later. And it pops on to the top of this perfectly. And what I'm going to do is I'm taking this microphone. This is a omnidirectional microphone. I bought this a while ago. There's no holes in the back, so it's not noise canceling. I'm going to put that in here, but I'm going to use a little bit of hot glue, a glue stick, to make a little bit of kind of like an O-ring type of placement. So when I put this in, it will only be resting on the O-ring made of plastic, and I'll kind of sandwich it in there so that it's not touching any hard plastic. It will only be touching a little bit of hot glue, and I hope the hot glue acts as a little bit of a kind of like a shock absorber so that any noise gets absorbed, and hopefully that will reduce any transmission of noise through the hard plastic. Now this is something I'm going to probably try using just to maybe make the O-ring with. I'm just going to play around with some ideas there. And I'm going to use this cable as a cable that connects to the microphone, a right angle cable, and very short. I'll tie a knot in the end here so that when I tug on this, the knot won't come out, and that will hopefully protect the microphone capsule from being tugged on. And I'm going to just desolder the microphone from this little setup. I originally had it connected to a battery pack, so it would be self-powered, but the GH5S doesn't need a battery pack. It's a pretty decent preamp, with a pretty decent power source, so I'm just going to desolder and try it directly. This microphone is omnidirectional, so I don't need holes on the side, and yeah, hopefully that will let me use this in Windy conditions, perhaps. It may not be as directional, but not every microphone needs to be directional. So I'm going to give this a try also. This is the hot glue O-ring I made. This is the knot I tied in the cable. So I have finished soldering it up, and I hot glued it all together, and I burnt myself a few times, so that's fun. And I'm going to test it out after I just see if I can clean the top up. I put some enamel, some clear enamel on it, and it worked out pretty well. If I put too much on, it kind of burns the plastic, so I just needed to put a light dusting of it on, and it worked pretty well. I got it from enamel for my car paint, so not perfect, but it seems to do the job pretty good. Got rid of all the white blemishes. So I'm outside testing the microphone we just made. This is the omnidirectional, picks up audio in all directions. It's snowing outside. There's not much of a wind, but just a very, very light one. I'm hand holding the camera, it's bloody heavy. But this is with the microphone. There's some traffic in the background, there's some birds chirping, and it's snowing. For comparison, this is the GH5S's onboard microphones. This is just for comparison against the omnidirectional we were testing. So I have the designs online for you to print out. This is the larger capsule that you can put either a large capsule in or some electronics in, or what I did was put some shock absorbing material inside, like you can use rubber or hot glue or something like that. This design is for two capsules, one here, one on the back. This back capsule you could turn towards you, so you can have front facing and rear facing, which is kind of cool. And the microphones for this I'll link to online. I tested them out in my video. I think they sound pretty great. And this design here just has room for the front capsule. So you can put the front capsule in the very front here. You can tie a knot in the cable here, and that will prevent it from being accidentally pulled out. And then you can just hot glue the end on. And you can download each of these parts individually or all together, do whatever. I would appreciate some community feedback on how I can improve these designs. At the end of the day, I'm ultimately building these for myself, but I enjoy sharing my creations with you guys. So if you're curious to see more of my creations in the future, or participating in development of any of these things, hit me up or leave a comment or subscribe. Thank you guys. I will see you next time. And just one last bonus idea. This is a golf ball dimpled microphone. I have it also hosted online. The idea here is maybe to reduce wind noise, I can make it look more like a golf ball. Maybe that will help reduce the sound. Anyways, lots of ideas. Please share your ideas. I would be very fascinated to see what you guys can come up with. So leave your ideas in the comment below.